everyone. Graeme and Zach here from Flow Software. Today we're getting into something pretty interesting, and that is how engineers pretty soon are going to be interacting with industrial systems. So quite a shift. We've recently released a new version of Timebase Historian, and quite excited. It includes an MCP server. So Zach, what's this all about?
Yeah, no, MCP is a really cool way for us to be able to interact with different software with large language models, right? Traditionally, access to data was done through something like an API. APIs, we would invoke them and then be able to get data out of them and be able to send that data to other places. The problem with APIs is they typically require us to write a service or a piece of code to be able to access that data, to be able to invoke that endpoint, right? And we kind of need to know some information about the endpoint. What are the inputs? What are the outputs? What endpoints are there even available for us to use? MCP solves this. MCP stands for Model Context Protocol. And essentially, it exposes tools in software directly to large language models. So instead of a large language model needing to go to an API, now it can see what tools or functions are available in the software for it to access directly. And this provides us the ability to be able to add data to the historian, to update metadata for configuration things, or to look at the data and get some insights from the data. One of the key things with Model Context Protocol that you guys will quickly learn about is the context. Context is king with MCP. And when a large language model interacts with the tools, it kind of needs to know what tools are available and how to use those tools. The context part of MCP is all of our tools have descriptions now. So now not only can the large language model understand, what tool to use in what type of situation, but how should the inputs to that tool look like? What are some things that it needs to be thinking about? And there's also what are called system prompts. System prompts are snippets of context that MCP provides to large language models that helps it understand specifics of the tool. Things like, hey, if I get this error message, what type of thing should I look at to start debugging, right? Or, hey, if I want you to do this type of workflow, maybe I want you to get data from multiple data sets. This is the most optimal way to do that, right? It's added context that gets provided to a large language model, something like ChatGPT or Gemini, that just allows large language models to integrate in a more natural, low barrier to entry type of way. So that's why we're seeing this huge upshift in MCP.
So for someone like me, Zach, if I'm interacting with this now, it's kind of like using ChatGPT, right? It's an assistant interface that I can now interact with my underlying Timebase historian. Is that kind of how it works? Is that one of the ways?
Yeah, absolutely. So we're actually going to show a demo today where everyone will see kind of how this works and what it looks like. But the MCP server becomes something that is accessible in any type of agent. So when you're interacting with ChatGPT or Gemini, you're using some type of client. You're, invoking the underlying large language model through this client. There are a number of clients that are starting to support MCP. ChatGPT made a major announcement that they're starting to move out MCP for their SDK and also some of their products like ChatGPT Desktop. But MCP becomes this external tool that large language models can access. So you'll be able to see what tools can the large language model access, and then what tools within that MCP server are available. So it becomes this really integrated way that's very easy to pick and choose what tools or what services you want your large language model to access, and then use it using the common tools that everyone's used to, just the ChatGPT interface or whatever your preference is from a client point of view. But it's a very easy, seamless integration.
It sounds very easy. I'm sure the underlying technology is not that easy, but this is the world of AI and the age of AI. It's magical. So apart from using that chat interface, what are the kind of use cases that we could think of when we specifically talking about Timebase historian? Where could it actually be used?
Yeah, no, absolutely. And then that's an area that we're just getting started with, right? We're going to constantly be finding new ideas and new really exciting things that were never really possible before. But with these new technologies like MCP servers and the idea of agents, these things are going to become, we're going to get new ideas and new innovative ways to do this. But some kind of low-hanging fruit that we've kind of thought about is configuration, right? Anytime you set up a historian, you have to configure the server, you have to configure, how do I get data, or what is the metadata on my tags? We can use things like MCP servers to manage that for us. Now we can use MCP servers to update metadata on tags en masse, right? We don't need to go in one by one and update them. We can ask it to describe something, and then it can update all the relevant tags with that metadata that we just added. Another really cool use case is for getting some situational awareness or understanding of data we might not really understand, right? One of the things that we'll show in the demo is the ability for a large language model to not only query the historian to see what type of data or what types of data sets are in there, but also look at these things like tag names, unit of measure, metadata, and that all provides context for a large language model. So it can go in there and not only see the data that's in there, but start helping us analyze, hey, what was the data for this filler over the last day or last hour? And were there any anomalies or any alarms generated that time? And then we can actually start to have it try to correlate things, right? So, hey, for these given things that have happened in these specific timestamps, were there any other data sources or data tags in the collector that we kind of have a common correlation with, how a certain alarm or event was raised? So MCP and these tools provide all these kind of capabilities to automate things that were traditionally kind of hard to automate. So what you guys see now, this is LibreChat, right? It is a web app that I just accessed through the browser, but it's that agent that is interacting with the large language model. And we're going to use Gemini for this demo. We're using the newest 2.5 Pro version. And then it has that MCP support. So I'll actually have it connected to Timebase Historian. And then we'll just be asking it questions, prompting it, and I don't even need to tell it to go to my historian. It will know, because that's an MCP server that is integrated with LibreChat, that, hey, when I talk about historians or data sets or kind of these data questions, it knows that's the MCP and the tools that I'm actually asking it to do. Before we get started, let me kind of just show you the data sets that we have in here. So let me just navigate to our running instance of Timebase. So in Timebase right now, I have two data sets. I have an Austin juice and a Phoenix juice. And these are just two simulated data sets that we're using for Timebase right now for the demo purposes, right? Just to have some pre-populated data, some tags in there. And it's supposed to be representative of what you might have in the real world. But just note, it is simulated data. It's not real life data. So there's, it's just kind of on a cycle, a loop, essentially, right? So we're going to go ahead and go back to the chat interface. And you can see at the bottom here, I have this Timebase Historian MCP server. So this is an MCP server that I've configured into LibreChat. So I'm just going to click on MCP server and click on Timebase Historian. And now when I chat with Gemini, it's going to know that and access the tools from the Timebase MCP server. So let's go ahead and play through that scenario that you had talked about, Graeme, right? Let's say I'm a new engineer, and let's say, out of those two sites, I'm working out of the Austin site. Let's go ahead and ask it, I'm new and I want to know more information about this data that's in the specific, the information that I'm going to actually want to know. So I'm just going to say I'm a new engineer at the Austin site. I've recently been asked to consume some of the data from our historian. I don't really know this data. Can you give me a general overview of what data I might find? Right. So I'm asking it, hey, I'm a new engineer. I don't really know the data that's in this historian. Can you just give me a general overview, right? And this happens so often in the real world, right? there's different functional groups, and they all know, what their data means. Controls engineers know what the tags mean. Managers know what these KPIs mean, right? So this is a very real use case that you might find in the world where someone needs to access data and they don't really know the underlying data, and we're using something like ChatGPT or large language models to ask questions in a natural language type of way to help us get more understanding, to help us onboard, to help us, speed up all these processes for accessing and consuming data. So I'm just going to go ahead and ask you this prompt. This is going to get sent to Gemini. Gemini is going to look at the kind of question I ask, and then it's going to know the tools from this MCP integration and know what types of tools to ask. So Gemini came back and said, okay, I can help with that. To give you an overview of the data you might find, I can retrieve a list of all available data sets in the historian. Would you like me to proceed with that? So just asking for a confirmation. So I'm just going to come back and say yes. And while we wait, you could see that this line with the purple circle here says ran get all data sets. So get all data sets is a tool in our MCP server. And the large language model saw that tool and realized, based off the context in our prompt, that this was the correct tool to call, right? Hey, I need to provide an overview of what type of data is. Let me first get a list of all the data sets.
So it's basically taken the language you used in your prompt and found an appropriate tool that we've provided through the MCP server to go and run on the Timebase historian and provide the results back to that large language model.
Absolutely. And right. You have it exactly right, Graeme. And again, that's that context, right? In MCP, all these tools have added context of what is the tool, what is the output, what is the input, and what are the appropriate uses of these tools. So the large language model is getting this through the MCP server that the historian is providing, and then the large language model invokes them based off of the context from the prompt. So you nailed it. That's exactly how it works, but that's the magic of MCP and the way that MCP is deployed and integrated within Timebase.
So let's have a look at what it's provided us here. It's telling us that it's got the two different data sets, the Austin juice, the Phoenix juice, and it seems to have even provided some more information.
Yeah, it's pulling some of that metadata that is part of Timebase, right? Not only do we have the name of the data sets, but we also have metadata around what's the size of the data set? How much storage is this data set pulling? What are, how old is the data set? What's the oldest collected value in that data set, right? So, MCP in this added context, it is pulling this metadata. It is using large language models to not just give you a simple JSON output, something you would expect out of an API, but it's actually wrapping that in a way that any human would be able to understand, right? It's using that natural language to provide an interface into our data.
Oh, that's amazing. So, all right, so let's take our example, our demo a little bit further. Let's say that I want to look at, I want to investigate some downtime that we experienced on filler 3.
Okay. Let's go ahead and prompt that then. So just
and again, like I'm the new engineer, or you the new engineer, you don't even know what tags are available for filler 3. So this is going to be interesting.
Yeah, absolutely. So let me go ahead and give a prompt. Let's just say that's a great overview. I'm being asked to do an investigation specifically on filler 3. And let's just correct that on filler 3, specifically for downtime, right?
Mm-hmm. Yeah.
I don't know what data is collected in the Austin data set. Can you give me an overview and retrieve any relevant data for my analysis for filler 3? Right. So I think that was kind of what you were asking, Graeme, right? We don't really know the data. We know the data sets now, the Austin Juice Factory, because of the context and the way that it's named and the metadata there. But I don't know the underlying data. I want to ask not only what tags are in that data set, but also what is the data for those tags, right?
Right.
So we're just going to go ahead and prompt that. And, Gemini came back and it went ahead and realized this is kind of a multi-step orchestration process, right? So the first step is, hey, I need to get all tags, and then I need to create like a description of them, right? So, Gemini came back and said, first, let's find tags in the Austin Juice data set that are related to filler 3. One thing I want to point out with this response is, if you look at this doesn't say filler3.batch ID. Sure, it's abbreviated, and we know that because it kind of is an obvious abbreviation. But you can imagine this might not be as obvious, especially to someone that isn't in manufacturing, right? Maybe someone outside the manufacturing organization, they might not realize that's filler 3. The reason it's doing this is these tags in Timebase have metadata in them, right? So not only when we ask it to get tags is it looking at the name of the tags, but it's also looking at that metadata, right? And it's realizing that FL03 batch ID is associated with filler ID because there is a tag on the Timebase historian for metadata that tells it that it's for filler 3, right? So again, these are just. Oh, go ahead, Graeme.
I see for the state one, so FL003 state, it's even giving me information about the different states that filler can be in: idle, starting up, running, some downtime events like bottle starvation, bottle jam. It's got a whole lot of information that it's providing us. Where is it getting that from?
Yeah, no, that's a great question. So similar to the metadata and the fields that I was talking about, in Timebase, we also have a unit of measure, right? So let me go ahead and pull up the Timebase historian interface and show you what that kind of looks like.
Sure.
So in the historian, I can come into my datasets and click on Austin Juice. And here you'll just see all of the tags and the respective unit of measure and metadata. And you can see there's quite a few tags. I think there's 70 or 71 in the Austin Juice dataset. I can also filter on this, right? So we know the tag name was 03.state. So now I'm just looking at the one specific tag that I was interested in. And if you look at that, there's a few different kind of categories, right? There's the name of the tag, there's a description, which is like a human readable description. There's unit of measure, there's fields, format, and data type, right? Fields are those metadata, so they're like tags that people can add to the tags to be able to get more information, and that can be user defined, right? This other one, and the one that you're specifically asking about, Graeme, is the unit of measure. So tags in Timebase have a construct or a property called unit of measure to help us understand what are the actual units for this, for this state. So if you were to look at, the actual machine value that's probably being output from the actual filler machine, it would probably be something like an integer or maybe a byte or, some other type of data source that's not really human readable. What we're able to do at Timebase is define a unit of measure, something like an enumeration that says, hey, if this value is a 0, it actually means idle. If it is startup, it actually means it's in startup, right? So these unit of measures can be defined to help make things that are traditionally not as human readable in a more human readable format. Well, this unit of measure, because we've defined that, now also becomes context. It also becomes metadata that can be fed into the large language model, right? So the large language model is just kind of deducing, hey, these are important pieces of context for when we're looking at state. We're actually talking about things like startup, running, bottle starvation, and that is helping it understand of what state actually means, right?
So what you're describing, it sounds to me like it's almost like the guys that designed Timebase Historian have built it with AI in mind.
Yeah, it sure seems that way. We're not biased at all.
Okay, that's very cool. So it's great that the AI has picked up on all of that metadata and it's now sharing it to the user, to the operator, the manager, the engineer, whoever it is, right here in the chat window.
Yep, absolutely. So let's kind of continue through this kind of scenario that we're playing, right? Hey, I was a new engineer. Now I know, my boss asked me, go investigate filler 3. Filler 3 is continuously having this issue. I want you to go do a root cause. I didn't know anything about the data or the data sets. Now I kind of have an understanding of, hey, maybe state is something I want to look at, right? State seems like it's talking about when the machine's in an idle state or an error state. That's probably something I want to do when I'm doing some type of failure analysis, right? So the next natural thing would be, hey, I want to go ask it for a specific time range. What was all the different data values for state over the last day or over the last hour, right? So we can actually ask the MCP and the large language model to provide that for us, right? So let me kind of give an example of that. So one of the things it was asking me for is, could you please provide the start and end times? So it's already kind of knowing where I'm going with this based off of just kind of the context and the things that I'm asking. So it's kind of already anticipating this. But let's say I'm going to go ahead and give it a time range of what I want it to aggregate and ask it to go ahead and give me like a report or a table. So I'm just going to say it's 5:22 at 11:50 a.m. I'd like to look specifically at the state. Look specifically at the state tag data over the last day. So let's just say, hey, I want to look at the all the state data for the last day. Can you please output all the data in a table, a detailed table, right?
And I see. So even though it's asked for a start and an end time, you're telling it what the time is now, and then you're just asking it, give me the last day.
Yeah, absolutely, right. And that might be, different type of relative, right? I'm asking it, give it the last day. If I had a specific time range, I could pass in a specific time range, right? Yeah. Hey, give me this UTC time on this date to this UTC time on this date. I can do relative.
So you can be very specific if you want to be, but you can also just use natural language like humans do.
Absolutely. Yep. Absolutely. So we're going to go ahead and run this, and let's see what it comes back with. But ideally, what we're going to get back is, all the results from the data kind of going from this conversation we had, right? So the Gemini came back. It said, yeah, I can retrieve that data from state tag from the Austin Juice data set. And it kind of tells me the date range for the last day based off of the time that I gave it. You can see it actually calls our tool get data for multiple tags. So this is a tool defined in the Timebase historian MCP. And then not only did it retrieve and ask for that data and retrieve that data, now it's outputting it in that format that I was talking about, right? And if I were to go look at the raw data for the state tag, I would see these values, right? I wouldn't really see these state descriptions. Again, large language model, and Gemini, it's smart to know the context and that, hey, a human's not going to want to just see like a integer value, that we're actually going to want to see the associated state with that integer value, right? So it's actually mapping for me automatically, even though I didn't prompt it to do this, the actual state description, right? So I can very easily look at these things and look at these state descriptions and look at the quality and their timestamps to start to understand these things for the last hour of data, or last day of data, sorry, right? And I can kind of see
quick and easy.
Yeah, absolutely. And I can kind of, just looking at this data really quickly, I can kind of see kind of a natural cycle with the filler, right? We go through an idle, we start up, or at some point we're running. Maybe we hit like an error state, like we either have a bottle jam or maybe a bottle starvation. Maybe we have to go offline for some maintenance. Maybe we're doing some cleaning or stuff like that. But you can kind of see there's some discrete changes in state, right? We're going between running state, error states, and maintenance states. And then if you look at the bottom, it kind of gives me an overview. It tells me this is a good starting point for your downtime analysis. You can see where the filler was in running state versus other states like the bottle jam or things like that. And then it asks, is there anything else you would want to ask from me, right? So what do you think, Graeme?
I'd love to know how much time in that last day did it sit in a bottle starvation state?
So we're going to go ahead and do exactly that, right? So we have all that data. Let's ask the large language model to kind of help us process that. So how much time in that last day did the filler, was the filler
Yeah.
in the starvation state, I think is what you said, Graeme?
Yeah, bottle starvation, I think it says there.
And do you just want to know the total time, Graeme, or do you want to do average, or
just the total time is great? Maybe just to play the role here. So maybe I'm a manager, and we're starting to notice a lot of bottle starvation, which means our downstream feed is not keeping up. Mm-hmm. So, I need to point fingers at the right part of the site and get the people working to reduce that bottle starvation. So let's understand these numbers.
Okay. Yeah. So we're just going to go ahead and send this and tell the Gemini to output the total time for a specific state from the data that we returned from doing our query, right? So we're going to go ahead and send that.
And Zach, just while that's working there, I want to clarify something very quickly. Mm-hmm. So I don't have to run an additional piece of software to get this to work. This is built directly into the Timebase historian.
Yeah, that is correct. The MCP server, which exposes these tools and allows you to integrate essentially Timebase with large language models like ChatGPT or Gemini, it's baked into the historian directly. So you don't need to install anything. You don't need to download anything separate and configure it and stand up another container or do anything like that. As long as you're using Timebase historian and you're on the latest version of 1.1, it's as long as the historian's running, the MCP is up and running for you.
Correct. And I can, if I'm using a tool like this, or in the future when other tools that support MCP clients come online, I can plug into any LLM.
Absolutely. Yeah, we're using Gemini for this, just because Gemini is, easy to access and, it's a really performant model. I could use another provider, right? If I wanted to use Claude or ChatGPT, I could. I could even use a local model, right? Let's say in a real world example, like, in manufacturing, let's say I didn't want my data to be accessible by OpenAI or some of these public providers. If I had a locally hosted model, I could actually connect my client to that model and then use the MCP with that local model and do the exact same things we're doing here, but instead of Gemini or something like that, I'd be using that local model. So you can really use and match these different things together. But yeah, the MCP server is what exposes the historian tools to the actual model, right? So it's that actual kind of ability for large language models to access and use our tools, right?
Amazing. Great. So I see it's actually come back. It's invoked a fairly serious calculation there, but it's come back with a result for us.
Yeah, no, absolutely. So Gemini came back and it looks like it's, not only, aggregated that data and try to calculate that data, but it's actually written a small script here for us to process that, right? So
and then it's actually processed that script itself.
Yeah, it's actually ran that script. It's actually done things like parse the date and time and things like that. And then it's actually printing out the script into our chat interface, right? So it went through and looked at all of the times we were in the bottle starvation state and then aggregated them and then calculated the aggregate, what was the total time duration, right? And it came back with 15 minutes. So really, really quickly, not only do I identify, when and how often am I in bottle starvation state, but on average, what was the total aggregate of all those bottle starvation states over the last day, right?
Wow, amazing. And I'm imagining now if I had other MCP servers potentially connecting into other data sources, maybe, for example, my ERP system, if I could get cost information, I could translate that 15 minutes into an actual dollar value.
Yeah, absolutely. Yeah, and we're starting to kind of see this idea of agents and agentic automation really catch a lot of buzz in the industry right now. But you're absolutely right. These tools, these MCP server tools are things that can be orchestrated, right? So I could have an agent that maybe I have an MCP for Timebase. Maybe I want to get some data, but I don't know the correlation between all this data, right? Well, typically that's in something like a data model. Well,
Right.
you could imagine maybe we have a data model with MCP, right? So not only do I go and look at the raw data, but now I can have an MCP server to say, hey, how is this data related, right? What's the semantic relationship between these two data points, right? You know, one of the things that we're showcasing here is the use of AI. Large language models are really good as a natural interface for, you know, working with, different types of roles and people that maybe aren't domain experts. But we're always going to have a need for advanced analytics, things like actual time series, like advanced aggregations, and things that are specifically built for, like predictive maintenance and things like that. Well, imagine if those tools had MCPs, right? So now not only can I understand the relationship between the data by looking at my data modeling service, I can access the underlying data from my historian through an MCP, but now an agent can also try to run analytics that are exposed through an MCP and orchestrate that entire chain, right? So I think over time, we're going to start seeing kind of these integration pipelines where you have multiple MCPs and there's an agent that's automated and doing and orchestrating these tools kind of behind the scenes to really, speed up some of the workflows, but also do things in ways that we've not really thought of before.
Yeah, amazing. Okay, so now let's take this example a little bit further. You've been asked to investigate this downtime. Maybe we need to ask Gemini for some further information. What else can it find for us to help us investigate the reason for this bottle starvation, for example?
Yeah, no, that's probably a really kind of natural next step to take. You can imagine, when we asked it what tags were for failure 3, it came back with a few different tags, right? So maybe, we have these error states in the filler. Maybe I want to start understanding, are there other correlations in the data, in the other tags that, might cause an error state, right? Maybe in the bottle starvation, there's a specific product that's causing this issue, right? We should be able to see those types of things in the data to help us kind of start like a root cause analysis or kind of give us a starting point to look for, places to look. So let's go ahead and do that prompt. I'm just going to ask it, that's great. Can you, based on these bottle starvation states, can you look at the other data / tags to see if there is any correlation with the other tags and when we go into a bottle starvation state? I'm being asked to do a root cause analysis, and this might be a good starting point, right? So again, just like you said, Graeme, hey, I'm being asked to do something like a failure investigation or a root cause analysis. We kind of identified, hey, when are we in this bottle starvation state? But hey, do we see any other things that stand out in the data that might help us kind of give us a starting point to look at, right? So we're going to go ahead and run this prompt and see what it comes. And we're just waiting for the response now, right? So what I would expect this to do is, based off of our, data points and when we were in that bottle starvation state, I'd expect it to, try to figure out, what are the other tags that we should query that might be related to failure 3 for those specific timestamp ranges, right? So let's kind of see what it has done here, right? So Gemini came back and said, okay, this is a good approach for your root cause analysis. To help you investigate correlations, I will retrieve data for other failure 3 tags. So it's already looking at the right filler. It's kind of looking at some of these other tags, right? It's identified a few other tags to look at, things like failure 3 temperature, pressure, flow rate, flow total.
And I see it's even said it's going to look at the data from 2 minutes before each starvation event starts and 2 minutes after. So it's kind of said, I'm going to look at the data for these other tags for a window when that event actually happened. You didn't ask it to do that.
No, and that was a really good catch. I actually skipped over that. And you're right, it did do that. It's actually kind of understanding, what I'm asking and that we're looking at time series data, and it's kind of using its own training to know like, hey, I probably need to expand that window outside of just when the error state happened to try to monitor and see if there were other things that happened before the error state, right? So it just did that on its own, which is a really cool point. So I'm really glad you pointed that out.
It's amazing.
But yeah, it went ahead and got some tags here. And then it's fetching that data, right? So it's calling to MCP, it's getting data for these tags. So if I actually look at this, it's actually passing in all the tags that are relevant to filler 3, and it's passing in that time range for the past day, right? Or sorry, not the past day, but for that time range for that 2 window outside of the error state window that Graeme was talking about. And then, we're getting the data back. And, it's giving us, it looks like it's giving us a overview of, for those errors, what were some correlations, right? So for the first error state that it saw, which was at a specific timestamp, it's telling us the product was a raspberry. The filler 3 temperature was fluctuating, but it stayed in a roughly kind of consistent range. Told us pressure, it has a range here, but it didn't really vary too much. Filler 3 flow rate, it kind of pointed something out. It told us before the event, at a specific timestamp, the exact moment the bottle starvation happened, that the flow rate dropped significantly. So that's really interesting. It's not only knowing that, hey, the error state happened, but it's actually verifying some of the sensor data with that error state and correlating that, hey, flow rate has this correlation, to the actual fill rate, right? So this is really cool. It's kind of making some of these deductions based off the context that we provided in some of our data. But yeah, it's actually kind of giving us a starting point of things to go look at, right? And it's kind of coming back with this kind of brief description of, kind of doesn't really look like there's too much going on from a correlation point of view, which kind of makes sense, right? This is simulated data that, probably isn't going to be something that actually propagates and show up in the simulation data.
I see there, it's even saying, that it's got a tag for in-feed, but the in-feed doesn't have any data. So it's telling us, let's go and investigate that as well. It's really pointing out a couple of different options for us to go and look at to try and find our root cause.
Yeah, absolutely. And it actually points something out that I think is really interesting, right? It's asking it, was it offline, right? It's saying, hey, these other sensors have data for this time range and they're all populated. You don't have any data for the sensor. Was it offline, right? That might be something that, if you have thousands and thousands of tags, you might miss something like that. Now you're able to use something like AI, which is really good at bringing all this context in and giving you some kind of pointers or things to look at, right? So that's actually a really cool, point and kind of demonstration of, where something like this can be really valuable.
Absolutely.
So it's just running through this and doing all essentially all some of these different timestamps, right? So it kind of did the same thing for a different range here. But yeah, really, really cool use case of AI and what can be done here.
Well, Zach, there are certainly exciting times ahead, and thank you very much for sharing this with us. To everyone watching, we hope you're as excited about where we're heading with Timebase as we are. We're really enjoying this. It's really opening up some magical things for us, and hopefully for you. So just to recap very quickly, the MCP server is available in a beta form in the latest version of Timebase Historian. So go and get it. It's version 1.1.1. and it will be available for future versions. We're still tweaking it. We're providing more context to it. So it's going to get better over time. We'd love to hear your thoughts. We'd love to get some feedback. And let me just make one important note. Once this MCP server moves out of beta and into production, it will become one of our first commercially available add-on modules. But please, get your hands on it now, start playing with it, use it as much as you can. Thank you very much for your time. Thank you, Zach. And we'll see you all soon.
See you guys.